Okay, last time we spoke, hi, hey, hey, hey. Last time we spoke, we said we were gonna what? We were gonna look at best two after our previous exercise on best 10, but there's something that I need to look at before we delve into the best two. In fact, I think I will postpone best two for the next session because now I want to take care of something that is very important. We looked at a whole number. I remember one of our examples was 127, which you said we are going to convert by base 10, and you said we achieve this simply by what? Simply by dividing by the base. If you have a number, our normal number, when you want to change it to a different base, we divide by that base. So, but now that was easy because we divide by 10. What if this is with whole numbers is very easy, but what if we got what? What if we've got a number like 1, the same 127, but it's comma 631, let's say for argument's sake. How do we then deal with the comma side of things? All right, it was easy. The whole number side is easy. We what? We just divide by what? We just divide by the base. So we'll say 127 divide by 10, and we'll say we are finding tens and there's 12 of them. And before I do that, something else that I want to mention first. I want to let me mention this because I find it very critical. Instead of doing this, let me first say I know my number is composed of units, it's composed of tens, it's composed of units, tens, and hundreds. In this case, it could be more, but our number 127 is got what? It's got tens, it's got 100 yet, it's got what? It's got 1,000 yet. All right. So let's go back and say, if I take that number 1, 2, 7 and say, okay, I know there's units here. How about I start by finding units? I divide by 1. But let me divide by 1 like this. Divide by 1. And then we will say, oh, 127 is made up of 127 units. Yes, 127 times 1. 1 is a unit, so there's 127 units. So if I say, okay, now I want to find tens, then I'll say 127 divided by what? By 10, and I'll find 12 tens, and I'll say, okay, but what remains is what we're trying to find the tens from. We're trying to find the tens among the units, so whatever remains is the units. So this will be 7 units left. I think that clarifies something because I got questions that made me a little bit uncomfortable, probably skipping that because people were like, okay, you're just suddenly saying these are hundreds, these are whatever, but where you say what remains is units. Where do you get the units from? I mean, some would say it's I don't want to cause a question stupid. There's no question that is stupid, but we'll say it's not. Some will say, but we knew this. But let's just to highlight. We'll say, okay, now if I want to find hundreds, I must divide that number by hundreds. But because I know I've dividing by 10 twice is what is actually finding 100. So I'm actually dividing 127 by 100 in case people are confused as to why we're saying suddenly now we have 100. It's because I am dividing 127 twice, therefore I've got what? 100. Okay, and then what could not make the 100 was because I was trying to find these hundreds among what? I looked among what? Among the tens. So whatever remains is what? Is 2 tens. Okay. And then now, oh, I should have gone across. Now, trying to find thousands, obviously, I'm trying to divide 127 by 10 3 times. I'm trying to find 1,000 in 127. It will be a miracle. It's the same as simply saying 10 into 1. It will not happen. I'll have what? I'll have 0 thousands. And I was looking, because I looked here, I was looking among the hundreds. So that 100 was what? Was left. Okay. So as you can see, 100 is more significant than the 10, is more significant by what? Than the unit. Therefore, this is the most significant digit. And this is the least significant digit. This is the LSD, and this is the this is the LSD. That is the LSD. Okay. So, but my point here is, You can see now that this here is 10 to the power of 0. I'm dividing by 1, I'm dividing by 10 to the power of 0. At this point here, I'm dividing the original number by 10 to the power of 1. I'm dividing this original number by 10 to the power of 2. Even though dividing 10 to that is the same as dividing 100 into the original number, I'm dividing the original number, I'm finding thousands here, 10 to the power of 3. So what I couldn't find here, I was looking for units. So I found so many units. So these are 10 to the power of what? All of them are 10 to the power of zeros. Okay, after dividing by 1, basically all of it was units, but then this is also what? 10 to the power of 0, because this is left from the units. Okay, that is 10 to the power of 1 as explained, and this is 10 to the power of 2. Alright, this is very important. This is the whole number side. That's why I have to take it what? That way, because 10 to the power of 2 is more significant than what? 10 to the power of 0, which is a unit name. But what about that part? If I look at 0,631 now, 0,631, the decimal part, this here I cannot find tens here. What I can find here now is tens, because these are tens. These are what? 100ths. These are 1000ths. So I cannot find tens here, but I can find tens. So what do? I actually what? I actually divide. I'm going to say divide by 10. I'm trying to find tens. Okay. But the whole point, when I divide by a tenth, it's as good as me multiplying by 10. So you say, okay, if I divide by a tenth, I'm going to get what? I'm going to multiply by 10. I'm going to have 6,300 and what? 310. I maintain the same number of decimal units, of decimal points, and whatever escaped from that number of decimal points is actually my what? My tens. Okay, so I say, okay, do I find 100ths? I say, okay, divide by a tenth. Okay, now all I'm doing here is, what am I doing here? These are my carryovers, because I want to maintain my number of decimal places. So I got my tens from carrying over out of the what? Out of the decimal point. Okay, out of the comma side. They escaped to what? To the other side. All right. So then I say, okay, what then? Because remember, if I had multiplied by a 10 here, it would have been 6 comma. The decimal is this 6 will no longer be what? Be a decimal. So I would have made multiply by 10 is shifting my tens to the what? To the left side of the what? Of the, or moving the comma once to the right. Dividing by a tenth is the same as multiplying by 10. So it has the effect of moving my comma one side to the right, or it has the effect of what? Of shifting my tens to what? To the right. No, sorry, to the left of the comma. Therefore, they are no longer 10. So this is no longer a 10. This is no longer what call this on the fractional side. This is no longer on the what? On the comma side. It is now. That is why we know our tens move first. So the next one that will move is the hundreds if we move the comma again. So I'm gonna move the comma again by dividing by 10, dividing by a tenth, or if I'm dividing by a tenth twice, it's the same as me dividing by what? By a tenth, which is 100th. So now I'm trying to move my comma a second time, and now I'm shifting. I'm saying, tell me what is my 100th. So this is going to be 3,100. Okay, and therefore what we have, we've got these being the what? The tens. These being the tens twice, which is 100th. 100th is the same as what? Tens twice. Okay, 10 twice. All right, so this is a 10 times a tenth. Okay, so you can see my power is what? Is this is 10 to the power of minus 1. That's a 10. This is 10 to the power of minus 2. That's the 100th. Then now, so going further, you can see it obviously follows that if I divide again now, I'll have my what? My 1000th. All right, so this here will therefore be 1, and I've got zeros now. Doing it will not achieve anything anymore. If I go further, I won't achieve anything anymore. This here is the same as what? 1000th. Okay, I'm moving my comma. I'm still moving my comma and say, oh, the first one is the tens, the second one is the hundred days, or the second one is the oh, that's what I'm doing in effect. So this, remember, is the same as the what? The 10th to the what? 10 to the power minus 3. So you can see the base is still 10 here. Okay, the base is still 10. So we've got here, if you want to write it as a base, we'll say 10 to the minus 1. Yes, we are looking for 10 to the minus 1. This is 10 to the minus 1 twice. This is 10 to the minus 2. And this one here is what? 10 to the minus 3. Okay, so you can see now why on this side you have, remember that this is equivalent to, if I have 0,631, all I do is maintain the number of what? Of decimal places, and all I do is multiply by 10. Why am I multiplying by 10? Because dividing, trying to find the tens there, dividing by 10 has the same effect as what? As multiplying. So that will be what? That will be my carry, and I take my carries in this time around. So my 10th is obviously more significant than what? My 100th is obviously more significant than my 1000th. That is why this number will be taken downwards. So the whole number side, because the most significant is the deepest, we go upwards. Now with the comma side, the most significant number is the what? Is the first one you get. So you write our what? We write our number towards the what? Towards the furthest point you get to. So this here would have been the same as 6310 times 10. This will be what? 3100 times 10. I've explained why. And then this will be 1000. Once it's all zeros, there's no point in doing it anymore. It will keep giving us 00. Adding. Remember, with the other case, if we further divided by 10, if you go back to the whole number and you say, if you further divide by 10, what will it do? It will say, oh, okay, 0, remainder 0. So it means it's like the number here, remember the MSD is 0, so it's like I'm adding to the remember the MSD is the what? Is the leftmost number. So I'm adding zeros to the leftmost side. So this is like adding zeros here, which does not change the value of that. Can you see? Also here, if I further multiply by 10 here, if I further multiply by 10, all I will achieve now is what? To get extra zeros, because this is going to be 0, 0, 0, 0, which does not yield anything. It's like me adding what? Adding zeros to the what? To the right side of the to the rightmost side of the what? After the comma. That therefore is effectively doing nothing. So once we get 0, either case, once we get 0, we know we are done. Okay, so in this case here, we know our number is taken from the most significant, which is the 10th, going what? Furthest as far as we want. So this is why you must understand why this side here we divide it by the base. This side here we multiply. Remember, 10 is our base, so we multiply it by our base. All right, so this is now a standard rule. I needed to explain this because we get a lot of situations where we are asked to work with numbers that have that they've got commas, and then we sometimes get stuck, probably not understand what we're doing. It's basically we look for tens here for sets of 10, but after the comma we can't talk of tens, so we start talking of tens. Okay, so we still say, okay, we're still looking, but now we're looking for tens. So the effect of looking for a tenth, we divide it by 10 to find tens, we divide by tens to find tens. That is the effect of multiplying. So on the right side of the comma, we multiply by the base. So remember, for a number with commas, a fractional number with commas, what am I doing? For a number with commas, for a number, what am I doing now? With commas, okay, we divide by the base for the whole number and multiplying our sound tautological and say by the base again for emphasis. I'll sound tautological. I will remind multiply by the base, divide by the base, multiply the base for the number, the fractional part, and number after the comma. I have explained why. Is it comma with the double M? You I'll probably should take my English classes. I'll look it up next time. I won't make the same mistake. Can't remember what a comma is. There's one comma where someone is lost consciousness, and there's a comma which we are dealing with here. So I can't really. I know the one is one M, and then the other one is double M. So, but in any event, I'm sure you know better than me on that part. So, anyway, I guess you understand now that when you have got a fractional number like that, a mixed number like that, one part, the whole number part, we divide by the base, but the comma part, we multiply by the base. We take the remainders up for reasons that our MSD is the furthest when we are dividing into a whole number, but we take our commas down because our most significant digit in that case here will be the first one. Okay, when you're moving commas, when you're moving the comma to the right to find what's what. But all I'm doing is moving comma right. Okay, I know after the comma, the first I get is the 10. When the second I get is the 100th. The third I get, and so on and so forth. So now, the most significant is the first one you get, and as you go further, you're going less and less significant, with the last one being the least significant digit. In this case here, this is for the decimal section, these are our least significant. For the comma section, this is our most significant, and that is our least significant. I won't mind 0 because 0 is actually useless. Okay, I wanted to clarify that because my issue now was going further, doing I was going to start dealing with numbers that have commas, and people are not going to understand why I'm doing what I'm doing. Okay, so I hope that was helpful. Now I promise the next session will be will be the binary. I wanted to tackle these two situations before I have to deal with the binary. Thank you so much. I hope that was very engaging. Thank you again.